All right, guys, welcome to Math 0106. This is lesson 13. We're going to be talking about how to do long division. So, to begin this, let's look at what we're going to do 35 divided by 4. So, I said 35, 34, yeah, 35 divided by 4. Okay. All right. So, one thing I want to make clear here is that division is, in actuality, group subtraction. So what we're doing when we're dividing is we're seeing how many times do I have to subtract 4 to get to 0. So if we keep subtracting, let's see here, how many times am I going to have to do this? Now, I'm a little concerned that I'm going to run out of space, but we'll just keep going until we do. And then something interesting happens at the end because it's not going to be another 4, because if I subtract 4, I'll get past 0. So let's see what happens here. So let's count though first off. So we see we can have 1, 2, 3, 4, 5, 6, 7, 8. And if we think about this, how much of 4 has to be subtracted from 3 to get to 0? It would be, we're going to subtract 3, right? So that would be 3/4 of it. Let's see what happens. So what we do when we typically do long division is we ask ourselves, how many times does 4 go into 3? Now, because 4 is bigger than 3, 4 doesn't go into 3, so we go to the next number, which is how many times can 4 go into 35? Now, if you know your multiplication tables, you know it's going to go 8 times because 8 times 4 is 32. If you don't know, then what you do is you just keep adding 4 until you get to the number until you actually get over 35. So let's do that real fast and let's see how many times I got to do this. I'm almost there. So that's 32, and then here we're going to get to 36, which by the way is 9 times 4. So what we do here is if I count, I have 1 here, 2 here. Notice when I count, I don't just count, I actually circle. And the reason why I do that is in case, just to make sure I don't miscount, and to separate the numbers that I'm counting versus the numbers and adding. So I did this, I went over at 36. So that means I can add 4 8 times, right? So hence that's where we're getting the 8 from. Then we take this value and this value, multiply them together to get 32. We subtract and we get 3. Now, if I wanted to, I could stop here and I could say 3 out of 4, or we could say remainder 3. This is where we said we subtracted 3 out of the 4, right? And that's where that remainder 3/4 comes from. But what I'm trying to stress here is that in reality, long division and division in general is just group subtraction. Okay, but we can also do this one other way. So we can let me actually just do this on another page here. 4 divided by 35. What I can do is, we know this goes in 8, this is 32. When I subtract, I get 3. If I want to write this as a decimal, now keep in mind, we know what this is. So 3 out of 4 is 3/4, which is 75 cents, right? So 0.75. So we know it's 0.75, but let's prove that it's 0.75. So I can tack on a 0 here. I can go 0.0 and bring this 0 down and repeat the process to see how many times does 4 go into 30. Now, the reason why I like looking at the green, the reason why I like to list is that you have it right here. You see it goes in 7 times because at 8 we're at 32. So if you didn't have your multiplication tables memorized, by listing, you can very easily see, it goes in 7 times. So we do 7 times 4, which by the way, if you didn't have memorized, it's right here. It's 28. That's the other benefit of this, is that you're basically writing out your multiplication tables. So 30 minus 28 is going to give me 2. Because I have a number left over, I'm going to tack on another 0. I'm going to bring that down, and I'm going to repeat the process. So how many times does 4 go into 20? It goes in 5 times. 5 times 4 is 20. Subtract, and we get 0. And then we get 8.75, which is what we knew it was going to be anyways. So that's in a nutshell how subtraction works, and also why subtraction works. Now, I want to emphasize this listing method. When I was first introduced to this, I wasn't a big fan of it. I was just like, look, I can do 4. I know 4 times 8 is 32, and I'll work with that. And if I don't know, I'll just guess and check until I get it to work. But what I have found since I've illustrated the guessing and check the listing method is I like it because if you have to do more examples, if you have to go further in, you're creating a list so you don't have to keep guessing and checking. So you're putting up more effort up front, but in the back end, you're putting in a lot less effort. And you're getting consistent values. Guessing and checking tends to make the propensity towards silly mistakes grows. So way better, I think, to just add until you get to the value. But let's do another one where we just go straight in and do long division. So we're going to do number 2. So here we have number 2. We're going to see how many times does 24 go into 82.08. So again, what I'm going to do is off to the side, I'm going to write 24, and I'm just going to keep adding 24 until I get to some number that is over 82. So 1 and 4 is 5, 5 plus 2 is 7, and we know this next one's going to go over. I'm going to go ahead and calculate it. Again, what I like to do is off to the side, I like to list, so 1, 2, 3, and 4. Okay, so now that I know that it goes in at 4, we go bust, and so we've gone over. Let's go use 3. So we're going to go ahead and put in 3. We're going to do 3 times 4. 3 times 24, which we already know from here is 72. And then I'm going to subtract. Now, what I'm going to start doing now is when I subtract, I'm going to start subtracting in a different color to make it stick out. So that goes 10. I'm going to put another 0. And I'm going to see how many times 24 goes into 100. Now, by the way, when you have the decimal, you want to make sure you put a decimal and align that. Okay, so we're going to see how many times 24 goes into 100. Now, I know the answer is 4, but for the sake of consistency, I'm just going to go ahead and add another 24. It's going to be 10, and it's going to give me 120. It's going to be 5 times. So at 5 times we go bust. So we want to use 4, and then we repeat. So 4 times 24. Now again, the nice thing about this is we know 4 times 24 is 96. We subtract and we get 4. We're bringing down these values, so we're bringing down the 8, and we're going to see how many times does 24 go into 48. Oh look, we've already done that over here. Let me actually change the color here. We've done that over here, right? We see it goes in 2 times, and I'm done. I mean, I can finish up the process and show that I get 0, but I'm done. The other thing that you can do here if you want, and I'm going to do it for this one, but I'm not going to do it for everyone, is you can take 3.42. If you multiply this number by this number, it should be giving you 82.08. So let me be clear here with what we're calling these. This is called, and you're not going to ever be tested on this, but I just want to give you the names. This is called the divisor. This is called the dividend. And the result is called the quotient. So I always remember this because the thing doing the dividing is called the divisor. If you read left to right, you end with the dividend, and the quotient, well, that's just the answer. But let's multiply this. Let's see if we do 3.42 times 24. Do I get back to 82.08? Let's find out. Okay, so 2 times 4 is 8. 4 times 4 is 16. Carry the 1. 4 times 3 is 12. Plus 1 is 13. Go down one line, 0. 2 times 2 is 4. 2 times 4 is 8. 3 times 2 is 6. Add. We're going to get 8. 12. Carry the 1. Another 12. And another 8. So we get, now notice because we have a decimal place here, we jump 2 slots. So here we jump 2 slots, and we get 82.28. Oh, look, I made a mistake. 6 plus 4 is 10. I said 12. I don't know why. But there, I'm using the division to check the multiplication, but you see the point. You get the same thing. So there you have it. So I'm not going to do that for every single one because it's just going to take too much time. but it's a nice way to check. If I'm doing long division on a test or say on a final, I'm definitely going to check by multiplying because it's easy to make silly mistakes. So here's the nice thing. All right, we're going to go on to the next one, number 3. So we're going to do number 3, which is 104 divided by 2.6. Okay, so what do you notice that's different here is that your divisor, remember the divisor is the number on the outside, here's the divisor, has a decimal in it. So what we want to do, an easy way of dealing with this, so keep in mind, let me put it this way, an easy way of looking at this is 104 over 2.6. So if I multiply both top and bottom by 10, I am not changing the number. And I'm curious if you know why. So hopefully you realize that 10 over 10 is 1. So I'm not changing a number. You can multiply any number by 1, and it'll give you the same number. So this will give me 1040 over 26. So in other words, if I move this decimal place over 1, then I just have to take the original decimal place and move it over 1 as well. And we're attacking the same value. So I always like to do that so that I just don't have any more decimals. And then we're going to attack the problem. So attacking this problem, we ask ourselves, how many times does 26 go into 1? It doesn't. Then we ask ourselves, how many times does 26 go into 10? It doesn't. How many times does 26 go into 104? I don't know, but I do know I can calculate it. So let's do that. So we're going to go off to the side here, and we're just going to keep adding 26. So 26 plus 26 is 12. Carry the 1. 2 plus 2 is 4. Plus 1 is 5. Keep going. Remember, we're trying to get to 104, so add another 26. That's 878. Not there yet. Add another 26. 8 plus 6 is 14. Carry the 1. 8 and 2. That's 104 exactly. Interesting. So we have 1, we have 2, we have 3, and then we have 4. So we know it goes in exactly 4 times. The beauty of this is that I know this, so now I can just go 104 here, and we're going to subtract. So this is going to leave me with 0. How many times does 26 go into 0? It goes in 0 times, and we're just going to keep getting 0. So the answer here is going to be 40. Again, I just want to show you that you would get the same answer if we just multiplied this out. We would get 0. 4 times 6 is 24. Put a 0. 2 times 0 is 0. 2 times 4 is 8. And when you add, you get 1040. So it's the same value. So there you have it. Cool beans. All right, next up, we have 2.7 going into 129.6. So again, we have 2.7 going into 129.6. The other way we say this is 129.6 divided by 2.7. So I want to stress that if we were to write it in the other notation, this is how we would write it. Okay, so same sort of game. Remember what we said last time. If we move this decimal place over 1, then we need to move this decimal place over 1. So we're going to have 27 into 129.6. And again, the name of the game is you look at 27, you see if 27 goes into 1. No. Does 27 go into 12? No. Does 127 go into 129? Yes. I don't know how many times it takes, but I know it does go in there. So let's figure out how many times it takes. So we're just going to keep adding 27. So 27 plus 27, 14, carry the 1. This is 54 plus 27. This is going to give me 11, carry the 1. This is 81. I'm not at 129 yet, so I just keep going. Add another 27. This gives me 108. Still not there yet. Add another 27. We're going to get to 135. Now 135 is over, so I know I can stop. I'm going to count how many. That's 1, 2, 3, 4. 4 is how many times it goes in, because 5 we go bust. So we know it goes in 4 times. Also note that I don't have to position that 4. You can position it wherever you want, but I always put it over where I'm putting the number into, so I can kind of keep the slots allotted. So I know I'm going to go here, and if I have to put decimals, then those will go here as well. Okay, so that's why I'm doing it that way. So 4 times 27, again, this is the beauty of it. Yeah, I've already done the work. It's 108. And then we subtract. This is going to give me 1. This is 2. 1 minus 1 is 0. And then we're going to bring down the 6. So we're seeing how many times does 27 go into 216. Now, notice I I've stopped at 135, so I have to continue. So I'm going to keep adding 27s now. So add another 27, 12, that's 162. Add another 27, that's 9, that's 189. Add another 27, 16, 9, 11, so that's 216. I'm trying to get to, yeah, oh, exactly there, 216. So let's keep counting. This is 5, this is 6, this is 7, this is 8. So it goes in an even 8 times. And there we have it. I mean, we could still, if you want to, you can multiply 27 by 8 and then subtract and you'll get 0. But that's as many times it goes in. The answer there is 48. Cool beans. All right, let's move on to the next one. 8.6 into 5.848. So we're going to do 8.6 into 5.848. So what we're going to do here is, again, we're going to move the decimal place over 1. We're going to move the decimal place over 1. So this is now going to give me 86 into 58.48. Okay. So note, this time when I move the decimal places didn't completely get eliminated, and that's okay. So again, we're going to do the same thing as before. Obviously, 86 doesn't go into 5 or to 58. So we're going to see how many times does 86 go into 584. So let's keep adding 86. So 86 plus 86, 12, carry the 1. 8 plus 8 is 16, plus 1 is 17. We're going to add another 86. So 2 plus 6 is 8. 7 plus 8 is 15, carry the 1. 258. We're going to add another 86. This is going to give me 14, carry the 1. 6 plus 8 is 14. Carry the 1 is 344. Remember, we're trying to get to 584, so we got to keep going. Add another 86, that's 10, carry the 1. 12 plus 1 is 13. Carry the 1, that puts me at 430. Still got to keep going. Add another 86, 6, 11. This gives me 516. Let's see here. I'm trying to get to 584, so I got to add yet another 86. I know I'm going to go over at this point, but I'm just going to add it so that for consistency's sake and in case later on I have to go over. So that's it. And then we're going to count how many 86s we have. 1, 2, 3, 4, 5, 6 is when we stop, but 7 and 7 we go bust. So we know it goes in 6 times. Then we're going to do 6 times 86, but we already know that 6 times 86 is 516. And then I'm going to subtract. So this becomes 14, this becomes 7, and we're going to get 688. You can also see as I've worked through this that division is a great exercise in adding and subtracting, right? So you're kind of working on all your skills at once. So now I'm going to see how many times, now I'm at 602, so I need to add another 86, but the awesome thing about this is if I add another 86, the 8th time is going to put me at 688. So I know this is going to be 8. It matches up. You can multiply it back out if you want to get 0, but we know it's going to work. And there we go. And there's our answer. It's 68. Okay, let's look at the next one. So next up, we have 0.74 into 0.37. Now this is going to be interesting. So again, we have 0.74 going into 0.37. So we don't like the divisor to have decimals, so we need to see we're going to have to move it over 2. So this one's going to have to be moved over 2. So we're going to have 74 into 37. But we notice that 74 does not go into 37 because 37 is smaller. So what we do is we put a decimal, add a 0. The exercise here is going to be to see how many times 74 goes into 370. So once more, we go off to the side, and we're just going to keep adding 74 till we get to 370 or a number greater than 370. So let's keep adding 74s. So that's going to be 5 plus 7 is 12, 222, add another 74. This is going to give me 6, 9, 296, add another 74. Remember, we're trying to get to 370 or beyond. 1, carry the 1, and nice enough, it actually gives me exactly 370. So now I'm going to count to see how many 370s I have. and then I'm going to have 5 370s. So this is actually just 0.5. And if you really think about it, that makes sense, because 37 over 74, remember, we can rewrite this way. If you double 37, you get to 74. So both of these are divisible by 37. And this is the other point that I want to make, which is it's very important to realize that to think in different ways. Because if you're just thinking along division, clearly this problem is a lot harder than if you think in terms of a fraction. So learning to think in different ways is going to make your life a lot easier. So hopefully that makes sense. Let's move on. So the next situation, number 7, is we are asking you to divide by 10, by 100, by 1,000, by 0.1, by 0.01, and by 0.001. So really, we're just going through each of these and we're dividing. And what we want to stress when we're dividing through these is when you divide by 10, ask yourself, are you making the number bigger or smaller? So clearly, if we're dividing by 10, the number is getting smaller. And if you're not certain of that, think about the fact that dividing by 10 is like the idea of cutting a pizza into 10 slices and taking one of those slices. So if you took one of those slices, it would be a lot smaller. So what that means is that if we're looking at the decimal, do we want to move the decimal to the left and get 3.58, or do we want to move it to the right and get 358? Well, clearly 3.58 is smaller. So we jump, and what we're always jumping is the number of zeros. So if we look at number 8, notice we have 3 zeros, so that means I'm going to jump the decimal place 3 times. So that means I would include 2 more zeros here, and I would have 0.000128. And it's as easy as that. So if I'm dividing by 100, 100 has 2 zeros, that means I'm going to jump 2 places, and I'm going to get 0.439. Now this is interesting. We're dividing by 0.01. So what I like to do on this one is to think of it as 13.807 divided by 0.01. Now when we divide by 0.01, remember 0.01, if I convert this is the same thing as 1 over 100. How do I know it's 100? Because I jumped the decimal place over 2. So we're doing 13.807 divided by 1 over 100. But we learned earlier in this course that when you divide, division is nothing more than multiplying by what? Division is nothing more than multiplying by the reciprocal. So this is 13.807 times 100. Now let's think about this for a second. Do I want to move the decimal to the left or to the right if we're multiplying by 100? So if I moved it to the left, we would change 13.807 to 0.13807, which would make the number smaller. That doesn't make sense, because if you're amplifying something by 100, the number should get bigger. So instead, we're going to move the decimal place the other direction, and we're going to have 1380.7. And that's our answer. So this was for number 10. Okay? So what we're doing is, if we're dividing, all you have to do is you have to count how many times it would take to make it a whole number. And for example, number 11, we jumped 3 times, and that's just how many times we move the decimal place over. So in this case, we'd be adding 2 more zeros in order to get the final result. So this one would be 45,300. But if you forget, you can always write this as a traditional long division problem, and you'd get the correct answer. So for number 12, all we have to do is, because we do have to just jump once here, we would just have to jump once here, and this would be 241.5. And that's it. So hopefully that makes sense. There are additional problems at the end of this section, but these are related to PEMDAS, so I'm going to make a separate video for that. So hopefully you're able to, what I would encourage you, if you've watched the previous video, you'd be able to handle the situations. They're just more complicated, but I'll work through them in the next video. In any case, hopefully this makes sense. Let me know what you think, either by email or you can post a comment. See you all in the next video.